Okay, now we want to try the exercise for this section, which is exercise 1. Okay, now let's try the first equation in this exercise. Okay, in each problems 1 through 5, so we want to see power series solution of the given differential equation about the given point x0 and find the recurrent relation. B. Find the first 4 terms in each of two solutions, y1 and y2, unless the series terminates sooner. And C. If possible, find the general term in each solution. Okay, for now I want to show you the first equation. So we want to solve y double prime minus y equal to 0 at x0 equal to 0. So we assume because we want to find the power series solution, so we assume our solution is in terms of y equal to n equal to 0, an x to the n. So y prime is equal to an x n minus 1, y double prime equal to summation n equal to n minus 1 an x n minus 2. Okay, so the first step, we substitute all of this into the given differential equation. Y double prime minus y equal to 0. So we substitute y double prime is n minus 1 an x n minus 2 minus y. So y is an x to the n. Okay, so the first step, we have to make sure our power of n is similar. So for this one, we want to make power of n is x kuasa n. Okay, to do this, okay, to make power of n is x to the n, so we have, okay, in here we have to plus it with 2. So for this one, we have to minus it with 2. Okay, so yang dekat sini tak perlu nak buat apa-apa because it's already x to the n. Okay, so we rewrite it. We have in here n go to 0. So n plus 2, n plus 1, an plus 2, x to the n minus an xn equal to 0. Okay, because the n is begin with 0, so we can combine it. Rewrite it as n plus 2, n plus 1, an plus 2 minus an x to the n equal to 0. Okay, so we want to find the recurrent relation. Okay, so we equate all this to 0. So we have n plus 2, n plus 1, an plus 2 minus an equal to 0. So our recurrent solution, so our recurrent relation is an plus 2 equal to an over n plus 2, n plus 1, and n is greater and equal to 0. Okay, so we have our recurrent relation is as an plus 2 equal to an over n plus 2 n plus 1 and n is greater n equal to 0. So this one is our recurrent relations. Okay, so the second question is to find the first 4 terms in each of two solutions. Okay, so we iterate our solution. So when n equal to 0, so will we have a2 equal to a0 over 2 times 1. Okay, and for n equal to 1, we have a3 equal to a1 over 3 times 2. Iterate again. When n equal to 2, we will have a4 equal to a2 over 4 times 3, or we can write it as, because we already have a2 equal to a0, so this one equal to a0 4 times 3 times 2 times 1, or a0 over 4 factorial. Okay, for n equal to 3, we will have a5 equal to a3 over 5 times 4 a3, or we can write it as a1 over 5 times 4 times 3 times 2, because a3 is a1 over 3 times 2, or this one we can write it as a1 over 5 factorial. Okay, and then n equal to 4, we have a6 equal to a4 over 6 times 5, or we can write it as, because a4 is 4 times 3 times 2 times 1, so we can write it as a0 over 6 factorial. Okay, and then when n equal to 5, we will have a7 equal to a5 over 7 times 6, or we already have a5, so substitute in a5, we will have it as a1 over 6 times 6. 7 times 6 times 5 times 4 times 3 times 2, or a1 over 7 factorial. Okay, because our solution is to find the first 4 non-zero terms of two solutions y1 and y2. Okay, usually y1, our y1 solution usually is we can see the solution in terms of a0, and for y2 usually we will find a solution in terms of a1. Okay, so because we only want the first 4 non-zero terms, okay, so our solution, we can write it as y equal to summation a(n)(xn), or we will have a0 plus a1x plus a2x squared plus a3x cubed plus dot dot dot, or we can write it as in here, a0 is a0, arbitrary, a1 also is a1. Okay, a2 we have a naught 2 times 1, or this one is also a naught over 2 factorial x square. So a3 we have a1 over 3 times 2, or this one is also a1 over 3 factorial. Okay, a4 we have a naught over 4 factorial x to the 4th. a5 we have a1 5 factorial x to the 5th. Okay, plus and plus dot 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 again. Okay, and then from this we can see that our solution is in terms of a naught and a1 only. Okay, so we can simplify it as, for a naught we will have a naught plus a naught over 2 factorial x square plus a naught 4 factorial x to the 4th plus a naught over 6 factorial to the x plus 6 plus dot 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 and plus for the a1 we will have, for the a1 plus, okay, so we will have a1 x plus a1 over 3 factorial x cubed plus a3 over 5 sorry, not a3, a1, still a1 over 5 factorial x to the 5th plus, for a7 we have a1 over 7 factorial x to the 7 plus dot dot dot. Okay, so for this one, as usual, we will have the terms with a naught coefficient is for y1 and the coefficient with a1 coefficient is for y2, or we can write our solution. Okay, so we have y1 as written and y2 as written. Okay, for y1 and y2 we can write it as a general terms. Okay, so for question C, the question asks, if possible, find the general term in each solution. Okay, for y1 we can see that it only involves the even power of x and also even factorial. On the other hand, for y2, it only contains the odd power of x and odd power of factorial. Okay, as we already learned, maybe in your subject before this, in calculus or DE, or even in high school, if we have even power or even a function, we can write it as 2 times n. Okay, so for y1, we can write it as, okay, I change the color of our pen. So for y1 we can write it as, okay, because all of this is in the even power of n, and the factorial also is in even numbers, so we can write it as our function or our series as, okay, so x times 2, or for this one we can write it as x to the naught, because x to the naught is 1. So for the even power we can write it as x times 2n, and also because all of the denominator is also in even numbers, even factorial, so we can write it as 2n factorial. Okay, same goes to the y2, because all of this is in odd numbers. Okay, so for the odd numbers usually we will write it as 2n plus 1. So we write the power as x 2n plus 1, and because the factorial also is in odd numbers, so we can write it as 2n plus 1 factorial. And if you recall the Maclaurin or Taylor series, this one also, this series also, we can write it as a naught. The series we can write it as cos x, and for the y2 we can write it as sin x. So that is the answer for question number 1. Okay, so I want you to try question number 4 and submit it through Oceania. Thank you.